Welcome back. So in the last couple of videos we've been working on just defining how the bytecode looks and adding some utility functions and doing some code that prints out a nice representation of bytecode. For example, here we make a custom allocator, it doesn't really matter, but then we make a chunk of bytecode, we add some constants and some operations. Then we disassemble it and print it. If we run that, we get something like this. But so we can look at bytecode. We can look at bytecode, but we cannot run it. And running some bytecode is the topic of this video. So let's start by creating a new file that we'll call it virtual machine, I guess. And it will be in the main package. And it will define a type, which I guess for now will just have a chunk of data, which will just be a pointer. So it doesn't really own the memory, you could say, in kind of Rust terms. It just references it. All right. We're going to have just a single global variable, which will be an instance. It will have type virtual machine, and we're going to operate on that. We'll never need more than one virtual machine in this project anyway, so that's why we do that. It will just make things easier that we're always referring to this global virtual machine instead of having to pass it around. Now we could make some functions that be like init virtual machine, and it doesn't actually necessarily take any arguments, and it will just do something like assign the virtual machine to, let's say, a new virtual machine, and that's about it. Also, we could have like a free virtual machine, which again is just some procedure that will probably just, I guess it's free virtual machine. So something like that. Let me see. There we go. And then in the main function, actually, let me just harpoon that. Then we would do something like init the virtual machine and defer free virtual machine. Let's try to run that. It did not work, and the reason is this is making a pointer. So actually we should do something like this is a virtual machine and the chunk is just nil. Can we do that? Right, it's not that, it's this. And then there's also no freeing it. So actually this was a bit silly. This data will automatically be freed, I guess, when the program exits. But actually we could imagine that there is some stuff, like maybe we want to free this chunk in here. I guess we can do that. So let's say free the chunk, and then inside main we'll say defer free via. Let's see if that works. It worked, even though the pointer was nil. But let's just remove that for now. And then what we want to do is let's keep this section that sets up the bytecode, set up test bytecode. Then what we want, we can print it, print bytecode for reference. And then we want to run this bytecode, and we can call it interpret. So we will have some function that takes a reference to a chunk and a pointer to a chunk and then runs it. So interpret is a procedure that takes a chunk of code, and it will return a result, which we'll call interpret result, and that is going to be an enum. So let me remember how you do enums. You do colon enum something. So interpret result is going to be an enum, and it will have a couple of values. And we can say it has an OK, a compile error, and runtime error. Right, and this guy was already a pointer, so forgot about that. And in here we need to just, for now, let's just return OK. And there we go. Now we're not really using the result yet, but I guess that's fine. Let's just keep it like this. Although let's move it below the disassembled code. Alright, so let's go into this function interpret. It takes a chunk. So what we can do is assign it as the current chunk. And then we also need an instruction pointer. Something like this, which we then need to add here, and we can make it an unsigned integer. It's going to point to somewhere, it's going to be implicitly pointing to a place in this code thing. Could also make it a pointer, but I think for now it's nice to have it just as an unsigned integer, just as an integer, instead of as an explicit pointer. But maybe we'll change that. But actually we could make it a pointer, so because that's supposed to be faster to dereference, so it's supposed to be a pointer to AU8, I suppose. Let's see if it runs. You cannot assign this guy to dynamic array. So perhaps I need to take the address of this. Okay, I guess. Actually, I just checked the Odin reference, and if you copy a dynamic array, it's actually just the same as passing a pointer. So we can do this, and that will be effectively what we want. Now, instead of returning just OK, let's return the result of running this stuff. So it's going to be a procedure again, which returns a result, and the default is probably going to be OK. And now we want to do something like for forever, like an infinite while loop. We're gonna read an instruction. So let's make a function that's called read instruction, and then based on what the instruction is, we'll do different things. So let's define this read instruction. And it's going to return a type of instruction, so it's just going to return a U8. Like that. So we're going to look in the global variable, the VM. We're going to look at the current instruction. And that is the value we want to return, actually this first one. So let's say value, but then we want to increment this. And I wonder if we can do this. So we move the instruction pointer one ahead. Actually, probably it's better to call this read byte, because that is what it's actually doing. And for operators with operands, like constant, it doesn't really make sense to say we're reading the instruction. So let's try this. And I'll just comment this out for now and maybe break. Let's see if it even compiles. And it does not compile. You know what, I said that this thing was going to be just like a pointer, but now I kind of regret it. Because we could keep it like this, and then here we'll say IP is now something like this. I think that would work. Maybe not. So what if we make it just an array? Then we can assign. So I think we're gonna go back to make it just a simple integer, like that. Now this doesn't work anymore, so we need to look in the code at the current instruction, and now it works. Sorry, I'm like changing it up all the time, but let's try this. So we say it actually really is a pointer. Then when we assign here, we're going to take the address of the first one. Then when we read a byte, the value is going to be the dereferenced guy. Then we increment it. Let's see if that works. Cannot convert untime value 1 to pointer to U8. So we need some way to pointer arithmetic. Okay, so it seems that if we really want to do that, we need to import the mem package and say that do something like this. The IP is now equal to mem.pointer offset and incremented by 1. So now we're actually using a pointer. I think that's kind of an interesting thing to do. We can do the other thing where we use just an integer index, but this is a good way to learn about pointer stuff in Odin, because it's a little bit different than C, so there's something to learn there. Anyway, let's now implement something here. So if it is the return operation, I already forgot how to write switch statements. Do we even have a switch in this project? Oh, we have this one. Right, so we do something here. If it is return operation, then we just return OK. And we're gonna make this partial for now. And this one will not do anything. Perhaps if we end up down here, which should actually be a runtime error. Because if we end up here, it means that there was no return up. Right, so here's the problem. This guy has type U8, and that is a problem because we need to cast it to a return operation, or sorry, an opcode. That's what it's called. So cast it to an opcode, and didn't like that either. It's called upreturn. So now it runs. And are we actually also interpreting this guy? We are. We are. So actually this return up, I guess, will also be used to return from functions, but whatever for now. So we can also have a constant. So if we have a constant, then we also need to get the value. So let's say we have something that we call read constant. What can we do with that? Well, for now, let's just print it. And then do nothing more. The read constant function procedure, what should that do? What is the value of constants? It's, I seem to recall that it's just called a value. So let's go in here and say it returns a value. And what do we need to do? We need to get the address, which is supposed to be the next byte. Then we need to get the actual value. So there's going to be VM chunk constants and address, and then we can return that value. And we don't have format, so I'll import that. Great, so now when we interpret this code here, this set of instructions, we can see that it starts to load instruction 0, it starts to run instruction 0, which is load constant 0. We just print it by now, we don't do anything. And then constant 1, constant 2, and we actually get out the correct numbers. So I think we're going to leave it for here. Now we have the basic setup for the virtual machine. We have a global virtual machine variable that is used to make it more convenient to work with. Then we have this run function, which is the core of the virtual machine, which is supposed to execute the bytecode that we will later compile from source code. All right, see you in the next one.